Robotics makes our life easier by automation of tasks, reducing manual efforts and enhancing efficiency. So what makes them work like this? If you open your laptop, you will find an electronic circuit inside it. If we analyze this electronic circuit, we can find numerous electronic components like IC chips, inductors, capacitors, and many more. All these IC chips work together and communicate with each other to make this electronic circuit functional. In electronic circuit, the two most important integrated circuit chips are microprocessor and microcontrollers. There are various similarities between them, as they are performing relatively the same task, but they are different in many aspects. They are different in terms of construction or integration, application in which they are used, processing of power complexity, cost, and also they are different in terms of power consumption. Let's see the major difference between microprocessor and microcontrollers. In terms of integration, microprocessor can be defined as the heart of computer system, and microcontroller can be defined as the heart of embedded systems. In computers, microprocessor is used as an CPU. So microprocessor is a central processing unit where it is required to connect input devices like keyboard and mouse, and output devices like monitor and printer. On the other hand, microcontroller can be defined as the heart of embedded system. If we observe the internal structure of microcontroller, it consists of a processing implement, a small memory, RAM, ROM, and EPROM. Microprocessor requires external components for memory and interfacing, whereas in microcontrollers, memory and output components are embedded. In terms of applications, microprocessors are used in a wide range of applications. Hence, there is no particular predefined task is required for them. On the other hand, microcontrollers are designed to perform a particular task. The basic example of microprocessor application is the CPU or the personal computer or laptop. On the other hand, microcontrollers are used for specific predefined tasks. A microcontroller works based on the input, whatever it is getting from either sensors or manual. Input from the keyboard or touch panel. In terms of complexity, microprocessors are powerful and capable of running complex operating systems. They are also capable of handling complex computational tasks. On the other hand, microcontrollers are simpler and less powerful than microprocessors. Microprocessors are powerful and complex. It is because they are capable in handling external timers and memory device. So for our next topic, we have the introduction to multi-core processing. In today's digital age, the demand for faster and more efficient computing power continues to grow. This is where multi-core processor comes into play. So what exactly is multi-core processing? A multi-core processor is an integrated circuit that has two or more processor cores attached for enhanced performance and reduced power consumption. This means that instead of relying on a single core to handle all tasks, a multi-core processor can simultaneously execute multiple tasks, greatly enhancing performance and efficiency. What are multi-core processors used for? Multi-core processor works on many modern computer hardware platforms. Virtually all PCs and laptops today deal in some multi-core processor model. There are several major use cases for multi-core processors, including the following 5. First is the virtualization, databases, analytics, and HPC, and the cloud. Example of multi-core processor. Most modern processors designed and sold for general purpose x86 computing include multiple processor cores. Example of the latest Intel 12th generation multi-core processor include the following. First is the Intel i9 12900 family, provides 8 cores and 24 threads. Next is the Intel Core i7 1270 families, provides 8 cores and 20 threads. So we have here the types of multi-core processor. First is the symmetric multiprocessing. All cores are identical and share the same memory. Next is asymmetric multiprocessing. Cores may have different capabilities and tasks. So for our third topic, we have the embedded system and application. Embedded system is a microcontroller or microprocessor-based hardware system that has pre-installed software embedded on it.
Some of the most famous uses of embedded systems nowadays are
automotive vehicles. They contain plenty of computer and embedded system are connected and programmed to carry out various specific functions in a vehicle. Next is phone. Within a mobile phone, embedded systems are used to manage everything on the operating system. Medical equipment. Highly complex embedded systems are often used in medical equipment as they are required to perform accurate and repeated action. Next, we have the industrial machines. Sensors and other monitoring equipments are controlled by embedded systems, since automation is a big part of most industrial machinery and much more. Embedded systems have a huge role to play in the future. With the advancement of artificial intelligence, virtual reality, and augmented reality, machine learning along with it, the embedded system will be the heart of huge industry and technology.